We're going to look at a couple different forms of linear equations in this video. After we look at the different forms of linear equations in this video, in the next video you'll be able to see how to graph all these different types. The most common type, the most common form of a linear equation and the most useful form that we'll find linear equations in is our slope-intercept form. This is the one that's used most often for graphing. When it's in slope-intercept form, we're going to have both a slope and a y-intercept. So y equals mx plus b. M is going to be our slope, and b is going to be our y-intercept. How is b our y-intercept, you might ask? Well, remember, to find y-intercepts, I plug 0 in for x. So if I were to plug 0 in for x in this equation, I would have y equals m times 0 plus b. So notice that m times 0 would become 0, so I do get y equals b. So my y-intercept, as stated up here, is 0b. Another form is the standard form of a linear equation. This one can be used for graphing as well if I can find the x and y intercepts. The only drawback to graphing from this form is sometimes the x and y intercepts, as you saw in a previous video, are not nice whole numbers. So sometimes it's hard to graph if you get a fractional or a decimal answer. But in this form, a and b are just any kind of coefficient. They could be any number. They don't necessarily represent a specific point or concept on the graph, and c is also just some constant. And then the last one, this one is most useful when we write equations, but you can also use it for graphing. It's y minus y1 equals m times x minus x1, where m stands again for slope. Oops. And x1, y1 stands for a point. The big thing is we need to make sure that we're able to change forms. We especially need to be able to get to slope-intercept form. Whether we start in standard form, point-slope form, our big thing is we need to be able to change any given equation to slope-intercept form. So we'll just look at a couple examples of changing to the slope-intercept form, so changing to the y equals mx plus b form. So notice that in the y equals mx plus b form, y equals mx plus b means y is by itself. So in each of these, I'm really just going to be solving to get y by itself. So notice on example 1, if I want to get y by itself, I can get rid of anything that's not attached to the variable first by using add or subtract. So I'll subtract the 3x from both sides. Notice these are not like terms, so I have to keep them separate. And then I divide both sides by -4. They cancel here, giving me y equals 16 divided by -4 is -4. -3 divided by -4 is a positive 3/4 x. So rewriting in slope-intercept form, I get y equals 3/4 x, either plus a -4 or just -4. And then looking at the next example, doing the same thing, I'm wanting to get y by itself, so I'm going to go ahead and first get rid of the 4x by subtracting it from both sides, giving me 2y equals 18, subtract 4x, and then dividing both sides by 2, leaving me with y equals, making sure to split and divide both of these by 2, 9 minus 2x. And of course I could always rewrite this with the mx first, just making sure that the sign belongs to the number it's in front of, so the minus 2x is still a minus 2x, and the positive 9 is still a plus 9. And that is it for the video.